If I tell you that even right now you are time traveling, then maybe you will laugh, but the truth is even stranger than that. We are all moving toward the future every second, but this normal speed is so constant that we never even feel it. Now just think, what if this speed could be changed? What if time was not the same for everyone? Then what would happen? This is where physics tells a very strange truth, that time is not like the hands of a clock. Rather, it is something flexible that changes with your motion. When Albert Einstein presented this idea, people thought it was just mathematics. But later experiments proved that time can actually stretch. This is called time dilation, and it means the faster you move, the slower time will pass for you. Now imagine, there are two people. One is standing on Earth, and the other sits in a rocket, which travels close to the speed of light. As that rocket keeps getting faster, time starts slowing down for him. His clock, his age, everything. When he returns, he will find that many years have passed on Earth, but only a few years have passed for him. This means that person has reached the future without any time machine. And this is not imagination. This effect has been measured in experiments with high-speed atomic clocks. Even satellites orbiting the Earth continuously correct their clocks because for them, time runs differently compared to Earth. Meaning, time is not a universal thing. It can be different for every observer. Now the question arises, if going to the future is so clear, then is it possible to return to the past? This is where physics stops us. Because as soon as you try to go into the past, you get trapped in a paradox. Suppose you go into the past and change an event that is connected to your existence. Then your present itself will change. And if the present changes, then you never went into the past. And if you never went, then how did the change happen? This is called the breaking of causality, where the connection between cause and effect collapses. In physics, this is a very fundamental rule, that every event must have a definite cause, and if this rule breaks, then the entire reality becomes unstable. Some scientists believe that the universe does not even allow such paradoxes. Maybe any process that could change the past becomes impossible on its own. But the story does not end here, because space and time are not separate things. They are parts of the same fabric, which we call space-time. If this fabric could be bent, if two different points of time could be brought closer, then theoretically a shortcut could be created. This is called a wormhole, a path that can connect both space and time. But the problem is, to keep it stable requires a kind of energy, which is still beyond our understanding. So does this mean time travel is impossible? No. It only means that we still haven't fully understood it. Physics does not tell us what is easy. It only tells us how nature works. And what we know so far is that traveling to the future is possible, but traveling to the past is still an open question. So the next time you look at a clock, remember, you are not just watching time, you are traveling with it. And maybe, one day, we will be able to control this journey. Till now you have understood that time can change, but the real game begins when gravity comes into play. Because just as speed bends time, gravity GDK pump time with equal power. Think, if you stand near a very massive object, like a neutron star, then time will start moving slower for you. And if that same place is near a black hole, then this effect becomes so extreme that time almost feels like it is stopped. Around a black hole, space-time bends so much that it becomes like a deep well, and the edge of this well is called the event horizon, from where returning becomes impossible. But something strange happens here. If a person goes near this event horizon, an outside observer will see him slowing down. Every movement, every second will stretch longer and longer, and eventually he will appear to freeze. But for that person, time will continue normally, meaning two different observers can see the same event in completely different ways. This is the deepest truth of relativity, that reality itself depends on the observer. Now imagine, if you use this extreme gravity, if you spend some time near a black hole and return, then on Earth, hundreds of years may have passed, and you would remain almost the same age, meaning you have jumped into the future. But there is also a danger. Near a black hole, tidal forces become so strong that they stretch your body. This is called spaghettification, where your body gets stretched like a thread. So does this mean time travel is just a theory? No, it means the laws of nature are very strict. You can bend time, but not without paying a price. Now let's talk about another strange possibility. If space-time is not just bent, but connected. If two distant points in the universe somehow get linked, then a shortcut can be created. This is called an Einstein-Rosen bridge, a type of wormhole that can connect two different times and places. Now imagine, if one end of this wormhole is moved at high speed and the other is kept stationary, then time will flow differently between them. And when you pass through this tunnel, you could emerge at a different time. This concept is not just imagination, it is possible in equations. But to keep it stable, we need negative energy, which is still a mystery in physics. And this is where science stops, because we still don't have a way to control this energy. But understand one more deep thing. Time does not just move forward, it is connected to entropy. Entropy means disorder. As time moves forward, things become more scattered. A broken glass never fixes itself, because the direction of time moves toward disorder. So if you want to go into the past, you would have to reverse entropy, and that is what makes it almost impossible. Meaning, physics is not just stopping you, it is explaining why time has only one direction. So now you have three truths. First, you can travel to the future. Second, extreme gravity can change time. Third, going to the past conflicts with the laws of nature. But the biggest questions still remain. Will these laws always remain the same, or will we one day find a way to break them? Because history proves what once seemed impossible becomes normal one day. So maybe time travel is still a dream, but not forever. And if that day comes, where will you go first? The future or the past? Till now you have seen time connected with speed and gravity, but the real mystery goes even deeper, because in the microscopic world where particles exist, time does not behave the way we experience it. Quantum physics tells us that a particle can exist in multiple states at once. This is called superposition, meaning, until you observe it, it does not decide where it is. Now think, if reality itself depends on observation, then can time also change with the observer? Some scientists believe that at the quantum level, time can be reversible, meaning, in equations, it makes no difference whether time moves forward or backward. But as soon as you enter the macroscopic world, entropy starts increasing, and time takes a fixed direction. This is why there is a deep gap between quantum and classical physics. Now consider another possibility: multiverse theory. According to this, every decision creates a new branch of the universe, meaning every possible outcome is real in some universe. So if you go into the past, you might not change your own past. Instead, you might create a new timeline where every action of yours creates a different reality. This removes the paradox, because now you are not interfering with your own history. You are starting a new one. But all this is still theory, because we have no direct evidence to prove the multiverse. Now the strangest idea, time loop, a situation where you live the same event again and again. In physics, there are solutions where space-time can form a loop. This is called a closed time-like curve, where moving forward brings you back to your own past. But whether these solutions are stable is still an open question. Now one final and deepest possibility. What if time itself is an illusion? Some physicists believe that at a fundamental level, time does not even exist. It is just our perception that sees changes in sequence, meaning past, present, and future may all exist together, and we are just moving in one direction, like a movie already made, and we are watching it frame by frame. If this is true, then the meaning of time travel changes. Now it is not about going somewhere, but about accessing that sequence. But one truth must be understood. Physics does not give answers. It teaches us how to ask questions. And the question of time travel is still open. We know that traveling to the future is possible. We understand that gravity and motion affect time. We have theories that try to explain the past. But we are still at the beginning, because the more we understand time, the more mysterious it becomes. So the next time you look at a clock, don't just see time. It is the deepest mystery of the universe. And maybe, one day, we will not just measure it, but control it. And on that day, history will not just be read, it will be lived.